Welcome to This Explainer. Today, we're deconstructing a primary math workbook to reveal the absolutely fascinating cognitive journey of learning how to count. It seems incredibly simple to us now, right? But the mental scaffolding required to truly understand numbers is literally a developmental masterpiece.
You and I take counting to 20 totally for granted, but getting a human brain to this point requires a brilliant, multi-layered architectural process. It's not just about memorizing a string of words. It's about building a solid bridge between the physical world we can touch and the abstract world of mathematics.
So we're going to look at this structural journey step by step. We'll cover visualizing numbers, the importance of sequence, discovering mathematical patterns, grouping objects, and finally, engaging our senses. Let's jump right in. Part 1. Visualizing numbers to 20. Let's start with the foundational step, which is how we first anchor those abstract numbers into our physical reality. Early on, the source material establishes three absolute core concepts as the foundation for this whole cognitive progression: count, number, and order. And these aren't just vocab words. They are the fundamental operations the brain absolutely needs to master to make sense of quantity. This brilliantly illustrates how early learning relies on familiar things to make numerical values visible. Think about a character, Vidi, who just tidied up. We aren't just staring at the symbol for 5. We are looking at exactly 5 apples in a bowl. We see 3 basketballs, 4 toy trucks, 8 baseball caps, 10 pencils. By tying that numerical symbol directly to everyday objects, the brain starts to realize that a number actually represents a tangible amount.
Moving to part 2. The importance of sequence. Once numbers are tied to real objects, the brain has to learn the rigid rules of order and sequence.
Imagine a number track, but it's missing digits. The material challenges learners to recognize numbers not just individually, but by their precise spot on a continuous line. Notice how some rows start at 1, but other times they start at 5 or 11. This completely blocks rote memorization right out of the gate and forces the learner to understand relative position. They have to stop and ask themselves, okay, what exactly comes before 16 and what comes after? So, the crucial point here is testing this sequence through specific, escalating actions that really push the brain to internalize it. Step 1, counting up builds the forward path. Step 2, counting down creates cognitive flexibility. It proves you aren't just reciting a song, but you're actually navigating a sequence. And Step 3, counting without looking, strips away the visual crutch, cementing that number line permanently in the mind. Part 3. Discovering mathematical patterns. From simple sequences, we evolve into understanding spatial relationships and predictability.
The text actually pauses here to ask a direct question. What pattern can you see? It's prompting the learner to actively observe and find the logical progression in the visual data. It's asking the brain to take a step back and really look at the big picture.
Now, what's super interesting here is how these cube towers map quantities from 0 to 7 straight to physical height. It creates this visual staircase pattern. Every time the number increases by exactly 1, the tower grows by exactly 1 block. This introduces volume and geometry to the counting process. It proves visually that 5 is bigger than 4, not just because it comes later in the counting song, but because it physically takes up more space. Part 4. Grouping shapes and objects. Next, the cognitive load really dials up as learners have to organize and count quantities across totally different visual layouts.
Check out how this complexity builds. We are comparing two very different types of visual organization. On one side, we have highly structured shape counting in uniform boxes, specifically 10 frames holding neat little circles, triangles, and squares. It's very linear and mathematical. But on the other side, we have scattered, completely unstructured organic groups of fruit, bananas, oranges, and apples placed randomly all over the page.
It's all about finding order in chaos. That deliberate contrast forces the brain to adapt its counting strategy depending on whether items are neatly categorized or randomly scattered. Because, in the real world, things don't always come in perfect grids. Learning to physically point or mentally track which scattered fruit you've already counted is a massive leap in cognitive organization. And that brings us to Part 5, engaging the senses to count. This is really the climax of our journey. The leap into purely abstract and sensory counting. Visual aids are stripped away entirely. Learners are instructed to look away and count purely by listening to coins dropping into a bowl. Picture a girl with her hand on her chin, looking up and away, completely relying on the clink of those coins to keep track. This is pure auditory processing. It proves that the concept of counting has been fully abstracted from visual objects. So to wrap that up, this curriculum achieves mastery through diverse learning pathways, making sure the concept of 20 is deeply ingrained. We didn't just look at numbers. We visually tracked familiar objects, physically traced written numbers to build muscle memory, discovered volume patterns with blocks, adapted to messy real-world grouping, and even counted by ear alone.
This is the architecture of basic cognition. These seemingly simple exercises actually represent profound cognitive milestones. They take a learner on a massive journey from physically touching an apple, to recognizing a symbol, to conceptualizing abstract quantities entirely within their mind's eye.
The text even bridges mathematics with a broader worldly context. Right in the middle of a counting exercise, it asks, what fruits do you know? Where do they come from? It's a brilliant reminder that learning is deeply interconnected across disciplines. Math isn't isolated. It's the tool we use to understand the natural world around us.
It really leaves us wondering, how many foundational skills do we use every single day without realizing the incredibly complex architectural steps it took to learn them? Every time you glance at a clock, grab a handful of change, or quickly judge which line at the grocery store is shorter, you are relying on this exact, multi-layered process we just explored. Thank you so much for joining me on this explainer, and keep questioning the simple things.